our last presentation is on the punching behavior of fiber reinforced concrete thin panels by Jamallah Nasari and myself. Yeah, Jamallah is here, so you can start your presentation.
Okay, Vijay. Hello, everyone. My name is Jamallah Nasiri. I'm a master's degree student in civil engineering department at Izmir Institute of Technology. My advisor is Assistant Professor Dr. Seljuk Satche. And the title of my study is Punching Behavior of Fiber Reinforced Concrete Thin Panels. The content of this study consists of the following chapter: introduction, which include objective in research significance, then the literature review. After that, I will give information about the experimental studies, which include preliminary test and current study. After that, I will present the result in discussion, and then I will conclude the presentation. I will start with the introduction. Punching failure occurs in flat slabs. Flat slabs are reinforced concrete slabs with uniform thickness, which are directly supported by columns without beams. And recently, flat slab become more favorable due to having the following advantages. The first one is it have easy formwork and reinforcement placement is easy. So it will reduce the period in cost of the construction. And also it minimizes the ceiling height, which will minimize the overall height of the structure in foundation load. So it will further reduce the relative material cost. And also it offers flexibility in room layout because of not having the beams in column capital. Despite this, punching failure is one of the essential risks in flat slab. So the punching failure is occurred due to high localized forces at the column support points. And it's a catastrophic failure because later or sometime no warning occurred prior to the failure. As we see in the picture, a disaster occurred in 1997 when the fourth floor collapsed due to the punching failure. Recently, over the past century, many researchers are performed to improve the punching failure. The first one is increasing the thickness of the slab. With increasing the thickness of the slab, it will increase the load of the structure, so which is not favorable. And the second method, using various type of reinforcement, such as flexure reinforcement, shear reinforcement. Using shear reinforcement, especially in thin funnels, it's practically not easy choice. So recently, researchers are interested to improve the strength of the construction materials, such as concrete. So fiber are the most used material to increase the concrete strength. The addition of the fiber to the concrete provide to bridge the cracks progress in the matrix. This behavior continue until fiber bricks will fall out from the concrete. As you see, the load deflection behavior of plane in fiber reinforced concrete. Here, a typical concrete member without fibers display a sudden loss of capacity after cracking, as you see here. However, fiber reinforced concrete continue to carry load after the cracking. The objective of this study are: the first one, steel fiber reinforced concrete is a relatively new composite and significant research effort. The second, the aim of this study is to investigate the punching behavior of steel fiber reinforced concrete in more general terms, focusing on effects of different type of fibers, fiber length and fiber ratio. Punching capacity of various steel fiber reinforced concrete is investigated. And lastly, the result obtained from this study are expected to contribute the characterization of the punching behavior of steel fiber reinforced concrete. Now I will present the literature review. The first one is Guia et al. In this study, punching shear capacity of steel fiber reinforced concrete flat slab is investigated. And the slab specimen were cast in octagonal form. and tested in simply supported system as showing here, and loaded by a hydraulic check from the bottom and through a steel plate of 200 by 200 millimeter. And the load deflection curve is showing here. They tested 5 specimens. The number after the numbers after the letter F represent the steel fiber ratio, and number after the letter R represent the flexure reinforcement. As you see here, the load and deflection capacity are higher in steel fiber reinforced concrete specimen compared to the one without steel fiber reinforcement. And this show that fiber give an important contribution to improve the behavior of flat slab. As the fiber content increase, the load in deformation capacity is increasing. The maximum increasement in steel fiber reinforced concrete was around 54%. The second literature review I will present is Tan in Venkateshwaran. In this study, the punching capacity of steel fiber reinforced concrete slab without traditional reinforcement was investigated. And they tested 12 square slab with dimension of 700 by 700 millimeter square. And the concrete class was here shown, in that 2 types of fibers were used. And the fiber content started from 0.25 to 1% in 4-5D as well. As shown in the load displacement curve, the type of fibers had marginal influence on the effect load. The 5D fiber displayed a slightly higher effect load compared to 4D fiber, with the exception of the M50, 56. And also the specimen 5D fibers exhibited higher ductility and sustained a large displacement compared to the 4D. In this study, all the slab specimens were failed in flexure. Now I will present the experimental studies. In order to determine an appropriate slab specimen thickness for the final test, a trial study was carried out. And in this study, 2 slab specimen was cast and tested with dimension of 170 by 170 centimeter square, and thickness was 5 centimeter and 7 centimeter. A steel fiber type of Duramex with aspect ratio of 60 and length of 80 millimeter was used, and steel fiber content was 0.5% by volume of concrete. And the funnel were simply supported on the 4 sides. And the simply support system was provided with a steel rod with diameter of 330 millimeter with the diameter. And then the specimen was placed on the top of this and loaded with hydraulic loading machine through a plate of 120 millimeter. In the load, the applied load in the midpoint displacement was measured. As we see in the load deflection curve, the panel with 50 millimeter thickness has lower strength and deformation capacity compared with the 70 millimeter. However, the general behavior of both funnels is very similar. In both funnels, flexure cracks occur observed first, extending from the midpoint toward the edges and form L lines. As the displacement increased, punching cracks began to form. And after the crack load with increasing displacement, the punching cone began to separate, and the load started to decrease in both funnels. The maximum, here as we see, the maximum strength achieved in both funnels occur long after the initial cracks, and displayed a very ductile behavior, as we see here. And if these funnels without traditional reinforcement were not having steel fiber, they are expected to collapse with the first crack, as here. So as mentioned before, the trial study aim was to define the possible thinness panel without losing its strength and behavior. So it was decided that the 50 millimeter thickness specimen would be appropriate to choose for the final test. Now I will present the current study. The mixed design parameters are showing here. The binder content in the fly ash to cement ratio is 1.2. The 3 types of steel fiber were used. Duramex with aspect ratio of 45 and a length of 35, 3D. in dynamics with length of 60 3D and dynamics with length of 65D. Here, the 3D represent one in hook geometry, and the 5D represent the double in hook geometry. Here, the mixture proportion, the mixture are named according to their content as follows. SF represent the steel fiber. Here, this one, the type of steel fiber, and steel fiber ratio by percentage, reflection reinforcement. Here, two specimen was casted with normal concrete without steel fiber, and one specimen was casted with reinforcement with the steel fiber volume of content 0.75, and one with the fiber volume of 1.25%, and the other was casted with 0.75%. The test geometry was adapted according to the trial studies. Here, just the supporting system was changed. Supporting holes were provided in this hole was considered in the forum work. And the slab specimen with the conventional reinforcement showing here, and the reinforcement was in forum mesh, in the form of mesh. So the test setup, simply supported system setup was used in the setup. The simply supported system was provided with a spherical washer, and this can just only rotate, but the horizontal movement was prevented. Here, again, a hydraulic load machine was used to load the specimen at the midpoint, and the load applied at speed of 0.025 millimeter per minute through a steel plate of 150 millimeter diameter. And here, a load cell was used to measure the load, and down as displacement transducer was used to measure the vertical displacement. In here, we see the data acquisition system was used to collect the data. Unfortunately, we don't have result of the current studies. So I will conclude my presentation. As we said in the literature review and trial study, additional fibers enhance the punching strength of flat slabs, and also increase the ductility in deformation capacity. In the presence of fiber in change the failure mechanism, passing from the flexure failure to punching failure. Here are some of my references, and thank you for your attention. If you have any question.
Okay, thank you, Jamallah. Are there any questions? Okay, so I guess there are no questions. So I would like you to thank you all the presenters and wish good luck in your all in your studies. So thank you very much. So this concludes our session.